Okay, now we're going to be assessing resonance structure using the rules that we said. So to see what structures contribute more to the hybrid, remember, first thing is octet. The greater the number of atoms with the octet complete, the better. And second is the fewer charges, the better. And if you're creating charges, then remember that you want to put the negative on the more electronegative atoms. That is, say, summarize it. And I'm going to do now a structure. Let's draw and here and talk about the contribution of the different resonance structures. So here's a bond, and I'm going to draw a lone pair here. That. So in that structure, let's recognize the patterns first. So here we see lone pair adjacent to a positive charge. That's one pattern there. And so also charge here is adjacent to that double bond. So it is allylic. That is like the allylic cation. So we can do a few things here. The first one that I'm going to do is I'm going to move electrons over here. And I'm going to create a double bond between the nitrogen and the carbon. And in doing so, I'm going to use a different color for the arrow. And this for the structure. All right. Still have my hydrogen there, but now I have this double bond. And notice nitrogen with 4 bonds, no lone pairs. So 4 non-positive charge. So that is one resonance structure. Let's analyze that structure. So here in the structure, we see that carbon, remember that we have 1 hydrogen here, but that means carbon has 3 bonds, so only 6 electrons around. So octet is incomplete here at the carbon. And here octet is complete at the carbon and is also complete at the nitrogen. It's got 4 bonds, so you count 2, 4, 6, 8 electrons. So all of the atoms, the octet is complete. So right there, this structure contributes more than the one in the left. So we're going to make another movement here. And starting from this one, I'm going to use another color because I'm going to draw a different resonance structure. We say that we recognize here the pattern of this charge being allylic to that double bond. So I'm going to do a different movement here. And for that reason, I'm going to use another color to give you another resonance structure. And we're going to assess that and see which one contributes more to the hybrid once we have the tree structure. Here I had a nitrogen, lone pair, and still have, now I have formed a double bond. Notice the arrow, the yellow arrow, let's say. And so we're forming a double bond here, and now we're creating a positive charge here. And now, analyzing, assessing that structure. I see that the octet is complete at the nitrogen. We're good. It is complete at the carbon, complete here. Here is incomplete. So of the 3 resonance structure, the only structure that has all the atoms with the octet complete is this one. So this is a structure that will contribute more to the resonance hybrid. So this is a major contributor to the resonance structure. And notice that even though that nitrogen is more electronegative than carbon, the most important rule is this one. So despite that we're having that positive charge on a more electronegative atom, this structure contributes more because octet is complete at all the atoms. Okay, so I hope that that helped you guys, and we'll see more of that in another video. You still recording? Oh, I'm gonna have to edit that.